up until this point,
Many ways.
12, we have had some fairly straightforward areas, right? They've either been above or below the x-axis.
Oh, to the sides?
Not quite yet, but we'll get there. So with below the x-axis, what's the issue with that?
I've already done to the sides.
It's negative, isn't it? Right? So when I'm looking at this question here, it's so important to graph it. Because in this case here, what kind of shape do I have again?
An S.
Yeah,
Like
straight.
a wiggly kind of
A wiggly
shape.
one.
Yeah.
Okay. Just like
What?
But, right, now I'm not just bounded by the x-axis, because unlike the parabolas, right, it's not really enclosed. But what does it say instead?
It just gives you points.
The lines
The
y
bounds.
equals 2x minus 1, which we'll say is here. And x equals minus 1, and x equals to 3. Yeah. So now I'm looking at,
It's bounded by the curve and the x-axis.
yeah, I'm looking at these areas here.
So do you plus them now because you're plussing like total area?
So if I,
That's where I got that plus from.
let me just think about it. If I just took the integral from negative 1 to 3, would that work?
No, it gives you 20.
Integral.
Yeah, why?
Yeah.
Why? What if I did something like this? What would happen? Well, have a look at the graph here, and what's the actual issue here? If there is an issue, what's the actual issue?
Yeah, to the,
Yeah.
the whole way across.
Yeah. Why can't I just do that to find the area?
Because you want to just find those two bounds.
So in this one, I could just go from.
I don't know.
I could just go
Yeah,
from.
I'm just.
I could just go from negative 5 to 5 there, right?
Could you use
And that
minus
works.
1 and 0 and
And that
3?
works.
Oh, because one's negative and one's positive.
Good, nicely. If you look at this here, right?
Right.
Think about when we had something above that was positive, but below was
Negative.
negative, right? So if I look at this one, if I actually just took the integral here, if I just took the integral.
Oh, so we have to absolute value.
Okay, so you want to try absolute value, Ben?
Yeah, right.
Just like this?
Oh, but we don't want to do the whole thing.
Why not?
Because one's not negative.
Okay, right.
Could you go like minus 1, 0, 3,
So you want to split it up? We are going to split it up, but let me just go back to Ben's idea of absolute value. The issue with taking the absolute value here is that we actually, when we evaluate this integral, we're already going to consider adding and subtracting this, and then the final result will be positive. Well, that's already too late, right? Because that negative area would have already been considered in your integral. Yeah. So we can't use an absolute value for the whole thing. That's not going to work. So we're going to use Jesse's
Oh, bang.
and Dylan's
No,
idea.
Dylan took it from me.
Dylan's idea of splitting up the integral. What, Jesse, can you tell me what bounds do I want to use?
I was going to use minus 1 and 0 and 3 and 0.
Okay, so 0 is my upper bound because that's the larger number in this case.
Minus 1 and then 3 and 0.
Good. So I'm going to add these two integrals together. Okay?
So
Yeah, the total
3 and 0.
That's where I got the plus from, sir.
Good.
Now
Don't confuse yourself. So here, it's really important to distinguish. You're going from negative 1 to 0, but this region here, right, it also starts from 0. Also starts from 0. And it's okay, it seems like there's an overlap here, but at this point here, right, there is no area.
Because it's just a point.
It's a point, exactly. So we want to have that region be continuous. Okay. What this is going to allow me to do is, now that I know this is completely below the x-axis, now I can take the absolute value.
Bang.
Okay?
Oh, what?
So the area.
But we only do the absolute value of that first section.
Exactly. Yeah. Well, it wouldn't matter for this one. This is already going to be
Yeah,
positive.
so we
anyway.
just
Yeah.
repeat.
So the total area would equal to the sum of this integral, negative 1 to 0, and the sum of this integral from 0 to 3. We can actually do these at the same time if we're a bit ambitious.
Oh, I am ambitious.
Nathan, do you want to tell me the next
I was
line
kidding.
after we do the integrals?
So what, you just find the primitive.
Yep.
So it's just going to be, yeah, x over 4.
Yep. From 0 to minus 1 plus, and this one's the same primitive.
Yeah,
Yeah.
but it's 3 equals 0.
Good.
Double.
Over 2.
Becomes
41 over 2.
negative 1 over 4
Yeah.
plus what?
81 over 4.
81 over 4. And of course we want a positive area, because that's how we understand it.
Why is that a negative 1 over 4?
Because
That's
over
just how it works
so
out.
because over here, right, Okay, let me do it a bit slower.
Because I just put in my calculator and
Yep.
it's a positive
So
one.
over
Who wants
here,
to
right?
do? Transfer
In your
money.
first bound,
Yeah, but Jesse, the zero is
you're taking
minus
0
the
here, and then you subtract the lower
I
bound.
can pay anyone.
So that lower bound would be
Normally
positive.
1 over 4.
And you're actually subtracting it. That's why you get negative here. Okay?
Yeah, I know.
So,
So hard for
Do you understand this though?
oh no, I do get it because that's it. Oh, got you.
Okay, cool.
I just search whatever season, whatever.
And then you would get positive 1 over 4 plus 81 over 4. Is 81
Just
over
gotta
4?
keep on like clicking the play
Ah,
button until pop up.
41 over 2 is the answer.
McDonald's 11.
Cool. What is 1 over 2 1?
Units squared.
Look,